Have you gone with the pages I have sent as the book of PDF of the book given? Have you gone through or not? No, I think my Jamboard is not safe. Okay, I am doing the word only. Okay. Hope you can see this window.
Yes, ma'am.
Okay.
It's visible.
And I am recording this session. Okay. Because some of them told me that they won't be present at class. So I am recording this class. Now,
What
this
happened
is
with the Jamboard?
no, basically I have closed the Jamboard. Basically, I am seeing every second some anonymous panda, anonymous sheep is joining. Okay. I think that was unsafe. It's because the link was not restricted. Okay. For restricted view, I have to send separate, I mean, access to each and every one. Next class, I will try to do that. Okay. For that class, I am going through this. Uh, that is what document only. So please, you can close your the Jamboard. Okay. Today I am not using the Jamboard because there is some anonymous person is joining each every second. That's why. So you can see this white. That is, I am creating a new Microsoft Word document where I am writing, and I hope everyone is seeing this page, right? Can you hear me?
Yes, ma'am.
Okay, sure. Linear differential equations with constant coefficient. Okay, so we have gone through how to find out the CF. You remember how to find out the complementary functions of a given differential equation. I hope you have already gone through. That is dny dxn plus dn minus that is a linear differential equations of nth order with constant coefficients where that is this p1, this p2, pn are functions of x only, and this x is also functions of x only. We have first found out the cf, that is I have written this equation function of d f dy is equal to x. So CF is obtained from f dy is equal to 0. Solving this homogeneous equation, we have got the complementary. This CF is short form of complementary function, and I have told our general solution of this equation will be CF plus PI. So whatever be the form of these differential equations with constant coefficients, we will be first able to find out the CF from this homogeneous equation. Last class we have done this, how to find out this complementary function from a given differential equation. So first we will equate this part with the 0, that is we will make a homogeneous and we will find out the CF. So our class will be on how to find the particular integral. Now this complementary function will have all the arbitrary constants. Suppose I have a nth order differential equations, so it will have n arbitrary constants in general solutions, and all the arbitrary constants will be in the complementary function part. And for this particular integral, we will find a particular solution, and it won't contain any arbitrary constants, right? So my pi, how do we get my pi for the given equation? So it is f dy is equal to x. My general equation is f dy. Your x is a function of x only, and since it's only a ordinary differential equation, we will only have one dependent variable and one independent variable. That is, I will have my functions in terms of x only and y in terms of coefficient, that is differential coefficient. Okay, so now, so our pi will be given by particular integral. This is pi is particular integral. This pi will be, from this our y should be x, and this is our particular integral. This is y is equal to 1 by, we have to find out this term, that is y is equal to 1 by, this d is a differential operator. We have already given this equation. This capital X is a function of x. So here this is another operator 1 by fd. Now how do we calculate this 1 by fd? That is in terms of, that will be d. Now suppose my d is operated on x square, so you know it will be 2x. So 1 by d, 2x will be nothing but x square. Okay, this is the inverse operator of this, that is 1 by d is inverse operator of this. So this is, that will mean we have to integrate. Now our terms are given in functions of that is in terms of, say, d square means that will be the second order differential equation. So you have to integrate twice, right? In general, this method, there is a general method for finding these particular solutions, and since it contains every time you have to integrate, so it's a laborious process. So uh, the general method is applicable to all the differential equation you will have. You can apply the general method and you will get a solution, but that is some laborious method. But we know some shortcut method, so that our function that is this x is dependent on the form of this x. Suppose it is a function of sine or cos, that means our x is sine or cos, there will be a shortcut formula. If that contains some e to the power x terms, so we will use some another formula. So first I am just uh, demonstrating how we can solve it generally, then I will move to the particular part. Now suppose I have a 1 by ft. Okay, I am first taking a very simple equation so that, and the process will be okay. So our y is 1 by fdx. This is my pi, this particular integral. Suppose this fd is a very simple, that is, I a fast, only a single factor, d minus m, right? And if suppose it is nth order, so it may have n factor, some may be repeated, that is maybe some of them m1 m2 may be same, I don't know. This is a general form. Suppose your nth order is this, so it will have n factors. Okay, so first I am taking only a single one, that is 1 by fd x. My fd is simple d minus m1. So this will be nothing but 1 by d minus m1x. Okay, I am writing this as my pi, that is y is equal to, I am getting this pi from y is equal to 1 by f dx. So this is will be y is equal to this. So this will be nothing but, and you know it's a first order linear differential equation. This integrating factor is nothing but e to the power minus m1x. So if I multiply both sides by this integrating factor, so this will be, now we know I can write this ddx of, this is x e to the power minus m1x. So if we integrate both sides, okay, I have to close this, and this is automatically closing. Okay, I have to start it. Okay, again. Okay, you have to bear with me because my function is not working properly, this word. Okay, so what I have left with, that was y is equal to 1 by ftx, that was 1 by d minus m1x, so d minus m1y is equal to x. So I have multiplied by the integrating factor, and left hand side is y e to the power minus m1x will be x e to the power minus m1x dx. So, and That was the term with, so your y will be nothing but e to the power m1 x e to the power minus m1 x dx. So this is the general form. You can integrate step by step, and at every step you will get another term and that will be added with. So suppose I have another d minus m2y, so I will have another integration here, e to the power m2x here, and this. So if the term has nth factor, so it will be laborious. And another method is you can factorize this term as, suppose I may factorize in this term so that these n1 to nn is constant. So now you can apply this 1 by d minus, that is 1 by f dx will be all the terms, and for each term you will have a term like this. Okay, so your general solution will be, but thankfully in general we don't use these formulas because you have to then integrate n times. For this general formula you have to integrate, that is you have to do integration n times. So we try to minimize that operation. So your 1 by, basically this will be 1 by ft, your 1 by ftx will be nothing but n1 d minus m1x nn d minus mnx. So if your y is equal to 1 by ftx, so this will be this. So the solution of this will be e to the power, there will be n1 m1x x e to the power minus m1x dx. There will be n2 e to the power m2x, all the terms you will contain. Okay, so this is the term. That means I will get the general solution. I will find the particular integral in this way. Okay, so in general we don't use it unless it is absolutely necessary. Hope you have understood the process. And another thing I would like to ask, that from the next Thursday, can I take my class from 10:30? If there are no, yes, tell me, or you can write at the chat box. Okay, I am seeing the message. Okay, tell me. Someone has tried to say something. Okay, so 10:30 will be set. Okay, no problem. And have you understood the problem? That is okay. Thank you. So now I will use some formulas, shortcut formulas, so that I can easily solve the particular integral part. Now, my first formula is, and in your PDF given, the formulas are there, and also the proofs, that means how they have got the formulas, that is also given, right? So basically for your purpose the formulas will suffice, but If someone is interested how to, uh, that means how these formulas came, there as the processes is given. Okay. So now, suppose my x is right side, my general equation was in that form, p1 dn minus y dxn minus y. So this x, we have already declared that this capital X should be function of x only. Okay. So suppose this is a function of e to the power. Suppose I have a coefficient e to the power ax. Okay. Then our we know our pi is y1 by f dx. This fd we have that will be given in your given problem. So that will be 1 by fd e to the power ax. So the formula is 1 by fd e to the power ax is 1 by fa e to the power ax, provided your fa not is equal to 0. That means you have to just substitute a, that means the coefficient of x here, in the terms of d. Okay, I am giving an example so that it is clear to you. And suppose this fa is not is equal to 0. Suppose if for some terms, suppose this fd is d minus a phi d. That means if you put a and your fd is 0, so definitely there will be a factor like this d minus a phi d. So I can now calculate the how I will and it may happen you have a repeated root. So I am just first starting for a general method, so that only single factor. So 1 by 1 fdx is, my fd is this, so this will be d minus a phi d e to the power x. I have told you that our function x is in terms of e to the power x. Okay, so this will be written is this, y is equal to 1 by d minus a. Now I can write this, and obviously this should be not is equal to 0, and if it happens to be 0, the factor will come at this term, that is it may be repeated twice and thrice. So we will find a term phi a such that it is not is equal to 0, and the factor, if it vanishes, it will come in the terms d minus a or square or cube or something like that. So this is phi a is not e to the power x. Now this y is then d minus ay, d minus ay. Now you know you have put the value of a, that is you have replaced this d with a, so that will have a numerical value, because this is a constant coefficient, so this will be have some numerical value. So this is also a constant, so this will be nothing but 1 by phi a e to the power x. So this is a linear differential equations with constant coefficients. We know the first order how to solve it. So how we'll get the result? This I am just explaining the first only the single factor. So you can repeat the process in the same way, and you can have repeated factors. That is how it comes. So you don't have to explain this process in your exam or etc. You can just write down the formula. Okay. So your this equation is nothing but Now integrating factor will be nothing but e to the power minus x. I am multiplying this. So the left term will be d dx of y e to the power minus ax, and right hand will be, that is d of this, and this will be 1 by phi a. I can integrate these terms, and this is e to the power x e to the power minus x. I have multiplied with the integrating factor both sides, so there will be e to the power minus x terms, so that will vanish. So if I integrate this will be nothing but x e to the uh, x phi a. So your y will be x e to the power x by phi a. Now suppose you have a factor d minus a square, so this will be x square by 2. Okay, suppose you have a 3, so it will be x cube by factorial 3. That way it will continue. Should I remove it? I am giving you example. Suppose I have a equation like okay. Now your auxiliary equation is m square minus 5m plus 4 is equal to 0. So I will get m is equal to 1 and 4, right? So our complementary function will be c1 e to the power x plus c2 e to the power 4x. For any problem, first you have to find out your complementary function. Now just I am taking some time, I am closing all my previous Word file, okay, so that it won't create any problem. Okay, so this is okay. My equation was d square minus 5d plus 4 is equal to 80x. Your CF is C1 e to the power x plus C2 e to the power 4x. Now my PI will be 1 by FD is d square minus 5d plus 4. This will be 80 to the power x. That is 1 by d minus 1 d minus 4 80 to the power x. Now, if we put this coefficient a is 1 here, right? So I will put in this, if I put d is equal to 1 here, it will vanish. So I won't be able to use this. This phi is 0. So this will, I will put 1 here. 1 minus 4, 80 to the power x. 1 by ft e to the power ax is 1 by fa e to the power ax provided fa not is equal to 0. So I am putting 1 here in place of d because it is not 0 and it will vanish, so I cannot use this here. So my next term is 8 e to the power x minus 1 by 3. I mean, okay, and one thing you should remember always, this operator is operates on some function, so I should not write the way that is 1 by d minus 1 e to the power x. I can write this 8 here and 1 minus 4 is minus 3 here. Okay. Now I have just find out the solution 1 by d minus a e to the power ax. If it vanishes, then the result will be x e to the power x only. That I have just calculated how this x comes, right? So you can just put down your x here and you will, this is our pi. So the solution of this differential equation y is equal to cf plus pi. So that will be c1 e to the power x plus c2 e to the power 4x minus 8 by 3 x e to the power x. Now tell me if anyone has any problem with this form. That is, have you understood the process?
Ma'am, in particular, this one PI, there will be no integral constant.
Tell me if,
In this particular PI,
right?
there will be no that constant of integration.
I couldn't understand your problem because I have solved this. Right, you have your a is 1 here. So your 1 by d minus 1 e to the power x. Suppose I am solving this as a linear differential equation first order. So you know how to solve it, right?
Yes, ma'am. Yes, ma'am.
Okay, so you
That
will
I've
get on.
understood. That I've understood.
Okay. And it may happen that your factor is repeated here, right? So you will have another term x square by factorial 2 and x cube, suppose in fact last class I have done that integration. If you have repeated form. So how this x square by 2 comes? I think I have done this in the last class. Okay, so this is one form. Suppose you have your x, and remember this, it has only the e to the power term. Suppose it has a multiplication of x or x square e to the power ax, then your whole process will be different. Okay, so there are formulas for there are. Okay, so I am now clearing this. Okay, so that is formula number 1. We have 4 or 5 formulas only, so don't worry. And remember, you can use any of the methods you know. There is no restriction for solving, right? These are only tools that we use so that it is easier to solve, nothing else. Even you can solve it by the general method, that is solving for general integration for 2 times or 3 times. That will be difficult, but it can be done. Okay. Now, the next part is, suppose my x is factor of, and okay, I am giving you some example. Okay, so that will be your x is x to the power m. Okay, so my pi will be 1 by ft(x), that is 1 by ft x to the power m, and I will, that is I will expand the term here. And now okay, why I am expanding the term here? You know, in general this 1 by d square terms requires integration, right? And we know differentiation is easier than integration. So if my factor is in terms of power of x, and we know each time we integrate the power increases, so we won't get the solution easily, right? Each and every time I am integrating, suppose it is x square, the integration will be x cubed by 3. And if there is, suppose a nth order differential equation, so I have to integrate, so that will complicate it. So we try to do, that is, if I express it in terms of that is operating on, suppose d operating on some powers of x, it will be definitely easier to solve rather than integrating, because these 1 by these are basically integration process. No, now something, now I am saying that I am expanding the term. Now have, I think you know this type of formulas for binomial coefficient, right? You have this type of expressions. Remember the formulas,
Yes.
right? So now you can say, I am expressing this x. There are some properties it need to um, uh, it need to satisfy. But how do we use this as a formula expansion of operator? Now, okay, the exact proof, frankly speaking, I don't know, but that is, if I correlate each and every time, that is the expansion is equivalent to the, if we made this integration, right? Suppose we integrate every time in general way and integrate the whatever be the result, and if we expand it that way and operating on this factor, it will be the same. So we are using this formula right now. Okay, I don't know the proof, but there is a correlation that every time we encounter, we know that it is solvable in that way, because, but remember these are differential operator, and we cannot in general use this formula for any expansion on operator. Okay, but for this term only this is valid, and I may say this is using trial and error, and we have used this and found out that operating integrations on these terms and equivalent to this expansion operating on this. So we are using this that way. That is a simple formula. Otherwise you can have always the general options of integration. So suppose I have a uh, okay, example. I have to find out the example. D square minus 5d plus 6. I am taking this because I know the factorization is easy, and I am taking the only order 2 because it will be simpler. If I take it 4 5, that will term will be much more complicated, but okay, that will be the same way we can do, but I am taking it for simpler reason. Okay, so I may use this d minus 2 d minus 3 x square. Okay, this is my y, this is my pi. Okay, so what we can do, okay, I have to express it in terms of, and why 1 plus x y minus 1 minus x, because the term is general, is comfortable, convenient for us to calculate this. Otherwise I could have used this and we can divide it. So we try to make it in these terms 1 plus x, or there may be your any form of plus minus. That means you can have minus n, 1 minus x minus n, basically these four formulas. And since it is inverse, so it will you will have these two formulas, right? So you have to remember these two formulas such that we can use this in this expansion. So this is expansion. Now you can tell me I can expand it two ways. Suppose I am having only this factor, I will make it a simple term, that is, okay, I have just since taken this way, I am doing this first. I can factorize this term, right? D minus 2 d minus 3, so it will be d minus 3 x square minus d minus 2, right? That I can write it this way. So this d minus 3, I will make this, I am just explaining, so that's why I am writing all the steps. You need not write all the steps when you are comfortable with. Okay, okay, right. So I can, so this will be minus 1/3 1 minus d3. Oh, this will be plus, okay. This is 1 minus x minus 1 is 1 plus x square by, okay. Now since it is only 1, so I don't have any coefficients here. Since my terms is up to x square, I won't take the other terms because all the other terms will vanish. I can just write it that way, but And you know the differentiation that is operating d on x square. So you can easily do this calculation easily. And this 2x. And you can now you can plus minus the terms, and you can always solve this. That will be 1 by 4 2x, so that will be cross out, right? So that will be half x, and that will be half half, because there will be first term will be 2x, then there will be 2, so that will be cancelled out, so that will be half, so that will be nothing but half minus 1/3 1 by 6 x square, 2 by 9 and half, 2 by 9 plus 5 by 3x plus plus 2 by 27. What will be that? Half. So there will be, and d by 2, that will be 4.
1
Half,
by 4.
that will be 1 by 4. So that will be 4, 2 by 7. That means. Hey, this calculation, just please check it, this sum and something like. Okay, just check it, the sum. It's okay, right? It's okay. Uh, okay, this minus is half minus 1/3 is 1 by 6. This half minus 2 by 9 is 5 by 3, right? And this is okay. And okay, now what I am another thing I will do, that is, suppose someone expands this without factorizing, right? Then also the result will be the same. So it doesn't matter how you recreate those terms. Suppose I am taking it as a whole. I am taking it, right, 1 by 6, 1 minus 5t minus d square by 6. This is x square. So that will be 1 by 6, 1 minus 5t minus d square by 6 inverse x square. Now that term will be 1 by 6. First term will be 1. Second term will be 5t minus d square by 6. The next term will be 5d minus d square by 6 square. Okay, so this will be the first term will be 1 by 6 x square. The next term will be 5d operated on x square. So that will be 1 by 6 into 5 by 6 into 2x. Next term will be d square. So minus 1 by 36, 2. And remember, from this, the first term will be square, the next term will be cube, and the last term will be d to the power 4. So I will take only the square term, that is 25, 36, d square operated on, that is 2. So simplify this and you will get 1 by 6 x square uh, plus, okay, I have since taken out the common 1 by 6 here, so I have taken, so 5 by 3x, this is 1 by 18, and so this is 2 by 18, 1 by right. That will be same as the previous one, right? So I am trying to say it is your choice how you will expand it. You will always get the same result. Okay. Now there is another formula. If any steps, if you have any queries or something, so you may ask me. Next is your x is function of e to the power x multiplied with v, where v is a function of x, right? Then 1 by fd x, here x is e to the power axv, is e to the power ax 1 by f d plus a. That means your d will be replaced by d plus a v. And remember, we always write operator on the right side of this. That means I will write here, and this operator, you cannot write this by x by fd. That will be meaningless. You will have always your operand on right side of the operator, such that it will signify which is operating on which function. So that means your this operator is operating on v, and you know, for this type of product we in general use the integration, that is we have to separate with the product and first integrand, second integrand, and sometimes it is very laborious. So if we can use this formula, we will easily solve this type of problem where your right side function is given in this form. Like suppose I am having mm, this. Here your e to the power ax, a is 3 and your v is x squared, which is a function of x. Now it is, I can always write this as y is equal to x square e to the power 3x, and auxiliary equation is m square minus 2m plus 1 is equal to 0. So m is equal to repeated root 1 1. So my CF will be C1x plus C2 e to the power x. This is known to you. So Pi will be 1 by d square minus 2d plus 1 operated on x square e to the power 3x. So I will now apply the formula, right? So this is nothing but, we know I can write this as d minus 1 whole square x square e to the power 3x. Now I will replace d by d plus a. Here a is 3, this is the formula. I have just using the formula, right? And your, then your e to the power will be on the left side of the operator, so that means it is operated, already operated. We have to just operate this operator on x square only. Now this is nothing but 1 to the power 3x 1 by d plus 2 square x square. Just in the previous example, we have solved this type of problems that we will expand it in terms of d, and we will operate on x square and we will get the result, right? So I am just erasing this, okay? So this y is equal to d plus 2. Oh, I had this e to the power 3x here, d plus 2 here. So, oh, I couldn't just, I have to divide it by, right? That is, this is e to the power 3x 1 by d plus 2 whole square x square. So e to the power 3x 1 by, I will divide by 2, so that will be 1 plus d by 2 whole square. There will be 4 here, right? Since I have, this is square, so this will be 4 here, x square. So e to the power 3x by 4, 1 plus d by 2 minus 2, that is x square. So I will expand it e to the power 3x by 4 first term will be 1, and the formula is 1 plus x. This is n, so first will be minus nx. So your minus n into this will be simply d, and the next term will be n into n minus 1, n into n minus 1 by 2 d square, so that will be 1 minus 3d square by 4. All the other terms I am neglecting because that will be operated on x square. This term will be vanished. So this will be so this is my pi, and remember you can see you don't have any arbitrary constants here, all your arbitrary constants in the complementary function part. So you know your y is general solution is Ca plus Pi. So you will write this in the answer, and always please complete solution will be this Ca plus Pi. So you know how to find out this type of x is multiplied some e to the power term, and some this v will always be function of x. Okay, and there are only one formula left, so then you will be solve any type of problems. Okay. Um. Okay. You have to. Suppose I am writing this as 1 by fd, and I am writing your fd as another function of fd square. Then your general term, I am writing here this d square because just one step. Otherwise, suppose you have given any fd, so you are given any uh, differential this operator in terms of d square. That is all the terms you can written as in terms of d square. Then your 1 by this will be just, you will replace this d square by this minus a square, and your sign will be remain constant. If this is sin x, this will be sin x. If this is cos x, that will be, the formula will be same. Because nothing, if you differentiate twice, then there's the constant terms minus a square will come. So that's why this formula is derived. Now we will see how we use this formula. Your right side is function of sine, right? So this is your auxiliary equation is m4 plus 2m cube minus 3m square is equal to 0. Tell me what is your m? Here our a is 1 because this sine is 1, sine x is only sine, the coefficient is 1. So I will replace d square by minus 1, okay? So that will be 1 by, okay, I can write this for here, okay, write it. This square plus 2d minus 3, this is 4 sin x. So কিছু বলবে?
হ্যাঁ ম্যাম, যদি d টু দি পাওয়ার 4 টার্ম থাকতো তাহলে আমরা কি মানে
আচ্ছা ধরো ডি টু দি পাওয়ার 4 না থাকলে যদি ডি কিউব থাকতো তাহলে তুমি শুধু ডি স্কোয়ারের জায়গায় তো বসাতে পারতে, বাকিটা ডি টার জায়গায়। এইবার এটাকে আবার তখন আমি ইয়ে করব, রেশনালাইজ করব, দেখবে। আচ্ছা ধরো এটা তো তোমার -1 হলো, মানে আমি বলতে চাইছি তুমি যদি ডি কিউব থাকতো তাই তুমি ডি স্কোয়ারের জায়গায় মাইনাস বসাতে পারতে, ওকে? ডিটা আবার রেখে ডিটা থেকে যেত। এই যেমন ধরো আমার এই 2d কিউব থেকে আমি ডি স্কোয়ারটা তো আলাদা করে নিতে পেরেছি, সেখানে -1 বসিয়েছি, ওকে ওকে। সো দিস উইল বি 4 -1, so there will be only a -1, so -1 -3, that means this will be 2d minus 4, right? 2d minus 4, there is a minus sign here, and this is sin x. So now I cannot apply because this is simply d. So what I will do, minus 4, I will multiply by 2d plus 4. So minus 4, if we wish, we can take this as 8d plus 2. This is 4d square minus 16, right? So I will replace this d square by minus 1 square again. Now I will operate this d plus 2 on sin x, right? So the operation will be d of sin x will be cos x, and this will be 2 sin x. And now you can just simplify and have the result. So this is minus 4. That means it will be minus 20 minus 8. So minus will be and 2 by 5, right? So this will be 2 by 5, and this will be cos x plus twice sin x. So this is your pi. So your general solution will be, complete solution will be CF plus pi. Okay, so now you know all the formulas, that is 4 formulas, and now you have to apply it. Okay, I am giving you one example right now. Solve it, and for the others there are examples in your exercises in the given PDF. You have to solve the problems, right? So I am just giving you first only one problem so that you can solve it right now. Here your e to the power x, this is your v, function of x. Solve it and tell me what is your result. For this type of problems, your PI will be y is equal to 1 by FD x square plus 3 to the power 2x plus 4 sin x, and you will separate each term and solve, right? Have you solved the first problem? What is the result of this problem? Tell me.
Ma'am, y equals to c1 e to the power 2x plus c2 minus half into e
Okay,
power
C1
x sin
plus
x
C2 e to the power 2x plus
minus half e power x sin x.
minus half e to the power x sin x. So this is your PI, right?
Hmm.
Okay, this is also the answer. So this one you will be able to solve, the second one, right? And there are exercises in given, right? You will go through the exercises. There are, I think, at least 30 problems. You solve those problems and it will contain all the types. Okay, so I am ending here my class. So go through the examples and solve it.